today's class. Today we'll be talking about binomial distribution and Poisson distribution. I'll just go there and pick them one after the other and solve some questions. Then the tips that is necessary, then I'll give on to Ross. Osage, what can I do for you? You raise up your hand, Osage. Chester. Okay. Some of us don't know all these functions anyway. So we will be looking at binomial. From binomial, we move to Poisson distribution. And there is another thing called normal distribution. We might not touch that. All we need to do is the same idea you have from binomial Poisson. All you need, how to solve it. Once you have the probability, how do I solve this probability? Once I'm doing this, what do I need to do? Then what's the probability when it is what's the probability when they ask me to find the mean? Or what is the probability when they ask me to find the mean, to find the variance? How do I solve it? There are simple questions. All you need is just the formula. Once you know the formula, you solve it. They already give you all the elements. Just substitute it into formula, press your calculator on your laptop or on your system. Remember, I believe by now, all of us will have tried to be in our centers to know how to get calculator on your laptop or your system. If you've not done that, please, your first paper, I believe, is not statistics. When are you writing statistics, please?
The 15th of June.
Last paper.
It's your last paper. That's fine. Fantastic.
Yeah,
This is your last
paper.
Meaning that your first day, second paper, third paper, you should have located or get to know where exactly the calculator is being placed on your system. When you get to the center, please ask your operator, please, can you show me calculator here? Some of you complain that in your center, they don't allow calculator, but you can make use of the calculator on the system. Please, don't be a victim. It is better to be a victor than to be a victim. Go and once you know where the calculator lies, the case is settled. Let's move on to today's topic. As I said, binomial, and I will quickly move into that. On binomial, I will just read a few things here, then we'll go into the action. Binomial, we have binomial from Bernoulli. It's a kind of distribution. It's a discrete random variable distribution in which one or two possible mutually exclusive outcomes occur in trial or in an experiment. Binomial distribution is derived from the process of called Bernoulli trials. These are the mathematicians that did something. They name it after him, Bernoulli. So a Bernoulli trial results from experiments that has two possible outcomes. Two possible mutually exclusive outcomes. And one and only one of the outcome can occur in a trial. For example, let me give us an example. Is either you are a male or you are a female? Yes or no?
Yes.
Yes, sir.
Is either you are head or you are tail? When you toss a coin, look at it. When you toss a coin, remember two possible outcomes cannot come out of this. It's either you are present or you are absent. It's either you are defective or not defective. It's either you are accepted or not accepted. So these are the things that is either is true or false. So two things cannot occur in this case. And one of the things I want us to quickly look into is this aspect, because we use these aspects a lot. I mean, these aspects in your notes. And you will see as we are moving on, some of the things. What are the characteristics of binomial distribution? We have characteristics here, but I will explain it better. Remember, we've been doing probability distribution since. Under that, we have what we call success or failure. You remember. So success or failure that we are talking about, they are also inclusive in this case. So now for binomial distribution, then we have number one of the characteristics of binomial distribution is each trial results in one of the two possible mutually. Don't forget that word. I explained it in the last class. If you missed it, please watch the video. Exclusive, mutually exclusive outcome. Now, number two of the is the probability for success. That is probability. Let me write it the way I used to. Probability of success is represented by probability for success is represented by or probability of success is equals to P. Now, when probability of success is equals to P, then what is probability of failure? Is equals to 1 minus P, which is equals to Q. 1 minus P. That is, you know that the success aspect, the total probability would now be, the total is that
1 minus
P plus Q is equals to 1.
1 minus P.
So P plus Q equals to 1 means that, remember, the total probability you can ever get is this. Meaning, you cannot record only success. At times, you can have failure. How do we solve it? Let's look at the formula. Now, for binomial distribution, we have this formula P of X equals to, you still remember this? P raised to power S, Q raised to power N minus X. Or we can rewrite this one to be I can rewrite this one to be n combination x, p of x, q of n minus s, where what is n in this context? What is our n in this context?
Number of possible outcome.
Number of possible outcome for failure or for success, which of them?
Success.
Really?
Combination
Anyway,
of
that's
the
the
two.
number of trial. N is number of trial. Then S, who can tell us what the S represents now?
Number of sources.
Number of sources. Then what is our P?
Number of successor.
No, you can't call it number. P
Probability
is
of
the
failure.
probability.
Of failure.
No,
Of
remember
success.
the definition from here. P is the number of probability of successor or probability of success. Let's take notes. While your Q is the same thing as 1 minus P, which is the number of what? What is the probability of what, please?
Failure.
Thank you. Is the probability of failure. So you see that we already defined them. It all depends on the question you were given. You look at we have series of questions which we are going to talk about. Now, let's look at this. Somebody can ask you, what about n minus x? What do we call it? Remember, you already know number of trial.
Number of failure.
It would now be minus x, which turns to number of failure.
Failure.
Please take notes. When you have, okay, for example, let me explain in this manner. You have 10 apples. They now said, out of 10 apples, 10 apple represents, I'm just explaining this, why this one is number of failure. 10 apple is 10. 10 apple is equals to n. N is 10 apple. They now say, the good among 10 apple is 7. You now say 7 is x. It simply means 10 minus 7 is equals to what? 3.
3.
What happened to the 3? The bad one.
Failure.
The bad
Failure.
apple or defective apple. So from there, you can see that 10 minus 7 is equal to number of failure or number of
Bad
defect.
apple.
Is that okay? So now we can go ahead and solve the problem. Now, this is number of failure. Now, let's look at this question. Number 1. A 6-sided, remember die, is row 12 times. what is the probability of getting a 4, 5? A 4, 5 times. What is probability of getting a 4, 5 times? Remember, excuse me. Yeah, thank you. So remember, we add when you throw a die, you cannot get 2 outcomes at the same time, yes or no.
Yeah.
Yes.
You can only get 1 outcome at the same time. But they now say when you now throw that die, 4 appears how many times?
5.
5 times.
5 times. They want to know that we will have 4, 5 times. Now, solution. Don't forget the probability. Write the formula down. It is very simple. You know your combination that we did, combination and permutation. Please go and revise it. Kindly mute yourself if you are not talking, please. Thank you. P of x, px, p raised to power s, and q raised to power n minus x. What is n in this case?
12.
Why 12?
You know the
Number
number
of
of
times.
The dice was rolled 12 times.
How many times, please?
12
12
12
times.
times.
Okay, what now happened to, what is the probability of getting a 4, 5 times? What happened to that?
That means when it's thrown 5 times, we should get 4. I mean, when we throw it 5 times, we should be able to get 4 in that 5 times.
They are looking for it, but now let me explain. I just gave you this question so that you will appreciate how to maneuver yourself when you are given something question like this. N is equals to 12. You are right, because a die is thrown. How many times? 12 times.
12 times.
Start analyzing it. And always remember, what is the probability that 4 appear in a die? I taught us last week. How many sides do we have in the die?
6.
6.
So what is now the probability that you have a success 4 appear?
1. 1 over 6.
1
Over 6.
Over 6.
What is over 6?
1
Like
over
1
1
time
over
now.
6. Now, okay, let me put it this way. What is x? Our x in this case is what?
Number of sources.
Our p is equal to what? And our q is equal to what? Nobody will give you. They only give you this. So explain to us. Remember the definition of the formula. Go back to the formula and check. That's why I gave you the definition where I said y is S is number of sources, right? So what represents number of sources here?
5 times.
5. Thank you. 5 represents, that is, if I throw a die and the probability that I will get 5, I will out of 12 times, 4 will appear 5 times, means I have a success. I'm sure that I'm going to have 5. if you are doing the lotto, and they said you are going to throw this die 12, and you roll it 1, 2, 11, 12, and here is 4 times in different places. Are you not the winner? You are the winner, meaning you have a success. So here we have 5. You must be able to interpret it. Nobody will give you this. They will only give you a question and you'll be the one to interpret. Now, what is the Q? What is the definition for Q?
Probability of failure.
12 minus
Q,
5.
P, sorry. P, I mean P.
Is probability of success.
Probability of success is what?
4.
No.
It has
You are
not
missing
been
it.
found.
5 over 12.
Is 1 all over
1
6.
over 6. Yeah, 1 over 6.
Let me explain it. Probably, remember we have 1, 2, 3, 4, 5, 6. That is the die. Now, what is now the probability out of 12 times when I throw it, or what is the probability that 1 will appear is 1 all over 6? Probability that 2 will appear, 1 all over. Am I right?
Also. Yes, sir.
Yeah.
Each of them is 1 over 6.
Okay.
Yes, okay. You understand? Each of them, when they say what is the probability, is 1 over 6. I will show you something. Now, each of them, they have 1 all over 6 here, 1 all over 6 here, 1 all over 6 here. For each of them. Please mute yourself. Osage, we know you are here. Mute yourself. Now, if you had all of them together, let's do it. 1 plus 6, 1 all over 6 plus 1 all over 6. What do you have?
1.
Which is 1. Can you get now? If they ask you what is the probability of taking a particular value from, since you know the total, you know the number of outcomes supposed to be 6. That is, we have 1, 2, 3, 4, 5, 6. Then if I roll a die, probability that 5 will come up is 1 all over 6. That because we've added everything you see is equal to 1. So take note of that. So because if they use card now, the word card or whatever card, you must know that total of that card. And they said, what's the probability that I'm going to pick a joker? Or what's the probability that you are going to market? So now 1 all over 6 is because 4 can come up. Then it will be 1 minus P, which is the same thing as 1 minus 1 all over 6. What is the answer, please? The answer is what?
5 over 6.
5 over 6, thank you. Now, you cannot solve this question directly. You have to first of all solve this. You first of all know the combination. What is our N? 12 combination. 12 combination what?
12 combination 5.
But before 12 combination 5, what is the formula for combination? I taught you. So it did not teach us, it's not here now. Is N factorial over N minus X factorial and S factorial. Because we are using X, on a normal day is R we use there,
Okay.
but we are using X here, I put X there. I can also put R if it is anyone you like. Just be consistent and define it the same definition. So now we have 12 combination 5. You can press your calculator, don't waste your time on that day because you have calculator. If the calculator or your system don't have a scientific way, that is why you use this method I'm using. So We have 12 factorial over 12 minus
12
5
minus 5.
factorial, then 5
5
factorial.
factorial.
If you solve it very well, you have what?
We'll
You have 12 factorial over
over
7 factorial, 5 factorial, which is the same thing as 12 factorial. When you multiply it, this one will be, you can solve this one the way I solved it last time. 12 times 11, 10, 9, 8, 7 factorial. You stop at 7 because 7 is higher. Then you can say 5 times 4 times 2 times 3 times 2 times 1. So this one cancel this. Then when you divide this one together, what do you have? You will have 792. Now, that is not the question they asked us to solve. Don't forget. This is just 12 combination 5. That is why if you have your calculator, you can punch your calculator once and get it. You don't need to pass through all this. But in case you don't have it, please, you need to do this. Then, now the question now says, let's go to the question again. The question says, what is the probability of getting a 4 5 times? So I will know probability of 5 times will be what? Will be, okay, let me just write it this way. Probability of x, where x is equal to 5. Then we have 12 combination 5. Then multiply by p. Our p is what?
1 over 6.
1 all over 6 raised to power what? Then 5 over 6 raised to power 12 minus 5. So you have this one to be 792 multiplied by 1 over 6 raised to power 5 multiplied by 5 over 6 raised to power 7. So if you punch your calculator very well, what do you have?
Wow.
I hope you know how to punch calculator for this. Is there on your laptop or is there on your system rather, or on your scientific calculator? If you have it, just you see raised to power is there. I'm not too sure whether this one will load. Yes. Can you see my calculator now?
Yes, sir.
Can you see it?
Yes.
Yes, sir.
Yes, sir.
I just pick it from my system. I just type calculator, I search for it, and it come up. So I think you can use something like this.
This one is standard.
No, that one is ordinary, sir. It's not scientific.
This one is standard.
Which one is standard?
Your calculator, sir.
The one you are using now is standard.
What does it mean?
It's not scientific.
That is not scientific.
You can
Is it not for
You
you
can
to
see-
get the answer?
you can click the next on it, you will get the scientific.
You can do what?
Don't worry, we're not looking for scientific now.
Sir, the factoriality is not there. The sign is not there.
That
Oh.
anybody decide is scientific
Even me, I cannot get it in my science.
before the standard. Yes.
Scientific is here. Have you seen it?
Yes, sir.
Yes, sir.
Click scientific. Have you seen it now?
Yes, sir.
You have to pay for all this. So you can see, you can get scientific there. All you need to know how to use it. Is that okay? If you want square, you get square here. But if you don't need square, so have you just from this line, go to standard, from here, go to scientific. If you need any function, is here. If you need geography, I know your work is not up to this place. So for raised to power, you see the factorial is here. Madam Factoria.
I've seen it, sir.
So if you want to raise to power something, you use this one. For example, let me open this. I have to go back. So I think it's supposed to work like this. 1 divided by 6. Close the brackets. Raised to power what? 5. I'm not sure whether it will work. Is it working this way?
No, it's not working, sir. I tried it.
It's not working this way.
Not, sir.
No, I tried it.
It didn't work.
It didn't work. I don't understand. Which one it didn't work?
It's not working, sir.
The total is
that.
given.
Not working.
Multiply by. What do you mean by it not working?
So if we do raised to power, the number is given is out of this word, but if we do times 5, it's giving us 0.833.
Why will you say times 5?
No, I'm saying if we multiply raised to power using the x raised to power 2, the number is given. Let me do that again so that I'll tell you the
Not
number.
x raised to power 2.
The function on the keyboard is giving us x squared, right? So I'm using
not
that
x squared. This one, x raised to power y.
Y, okay.
Don't pick x raised to power 2, x raised to power y, because you don't know your y. That is why he now puts you.
Y, okay.
You press x raised to power y, because you will be the one to supply y. That is the meaning.
Sure.
S is the number you generated from 1 all over 6. So I don't know how you are getting your own. Multiply by
now.
It's working now.
Yes, sir.
Yes, sir.
5 divided by 6. Close the brackets. Then raised to power 7. Do you get this?
Yes, sir.
This is what you're supposed to get. This is the answer. And from that, you see the way I locate the calculator, that just do that the same day. Don't disturb yourself and click scientific. That is the essence of coming to class. 0.028. Then you can multiply it by 100 to know the percentage. Multiply by 100. So I'll just go there. Then multiply everything by 100.
That will be 2.842.
Exactly. You can see now 2.8425. 2.84%. Don't worry.
25.
Okay, put 29. Is there anyone? So are you there now?
Yes, sir.
Okay. So what do we need to do again? That is the probability they ask us to calculate. But now let's quickly look at it. I have another question here, which I want everybody to do it by ourselves. Is in our notes. Now you have idea of what is in the textbook. Okay, it says suppose it is known that the probability that a person in a profession will be at home. In particular, in a particular time of the day is 0.6 or 60%. And if a person call on 5 persons in the profession, at that particular time of the day, at that particular of the day, what is the probability of getting two of them at home? Of getting two of them at home. What's the probability of getting two of them at home? So now, how many persons are we talking about?
5 persons.
How many?
5.
5 persons.
So in this case now, if you are talking about 5 persons, let's solve the problem. Know your formula. The formula says what? N combination x, p raised to power s, q raised to power n minus x. Then our n is equals to 5. What is x?
X is 2.
X is 2.
S is 2 because it's the number of that question they are asking you. Okay. Then what is P? The probability of success.
Probability of success. 2
0.
over 5.
60%.
60%. God bless you.
60%, 0.6.
60% is 0.6. How do we know? Because somebody is asking that question. How do you know that it's 60%? Read the question line by line. The question says, suppose it is known that the probability that, now, for example, let me give you a scenario of this question. Number one, we all know a police officer will always be at the police post. Is either you do morning shift or night duty, morning duty or night duty, or afternoon, I don't know whether they have afternoon duty, or a medical doctor always be on call. Now, you will not see them, or a student, you always been in class during the day, except if you are resuming in the afternoon. As a student, you are in class now. What's the probability that you will be sitting at home? Assuming it's a regular or a normal class, you will be in class. As a profession or as a student. So now that's what we are trying to Explain. So what is the probability that they will meet you at home? So now what is the Q? Nobody will give you Q most times. Q is 1 minus P, right?
Yes.
This
What
one
is the
one
Q?
minus P. 1 minus P
Is what?
0.4.
0.4.
0.4. Thank you.
0.4. 40%.
Yes, because the other one is 60, the last one will be 40. Number of failure is what?
3.
Yes.
5 minus 2.
Yes, which is 3. Now, let's solve the problem.
5 minus 2.
I believe we can solve it now. And can we solve it? What is the answer? I'm waiting, please. Excuse me. Yes, solve it, and tell us the answer, please. Favor, what's your answer? Edith, John, what is your, don't touch it, just continue. Tell us the answer. We want to see the answer.
I'm confused, so.
You are do what? Confused, okay? Thou shalt not be confused. Mamako, where is your answer? Don't touch it. I've already put you there. Let me put you. So continue. You see the way you give your children assignments. Oh, yeah, go and solve this. And I gave you one now, solve it. I saw them at your back. Now I will call them to come and see your mom. You can do it. You can do it. Solve it. Osage, tell us what is the answer, please. Edit. What is your answer? You said?
I'm still working on it, sir.
Okay, yeah, continue. Kehinde Fagbemi.
On it, sir.
Runaway student. Where have you been? Friday. What did you get? People are silent, so why? Ahmed Sanusi. So tell us the answer. Everybody on it. How many? This is just a simple question. No? This is just a simple question. No?
Sir.
Yes.
My answer is 23040000.
Who is talking, please? Raise up your hand.
Jayoba.
Jayoba.
Yes, sir.
Okay. 2 what?
23040000.
My answer is 2304.
2.048. Okay. Okay. How do you guys get all these things you are telling us now? Okay, let's go to the board.
My answer is
We see.
Answer is 0.0497.
The question is this. We all have all the elements. Substitute the element there and punch your calculator. You understand? You don't need to waste time. You have how many minutes? Probably 1 hour. And you have over 70 questions. I don't know. So you have n to the 5 combination 2 multiplied by 0.6 combination raised to power what?
2.
Then 0.4 raised to power what?
3.
So if you punch your calculator very well, 5 combination 2 is what?
10.
10.
Do we all agree?
Yeah.
Yes.
Yes. If it is 10 multiplied by 0.6 raised to power 2 multiplied by 0.4 raised to power 3. Let's use our calculator here so that we know how to use it very well. So we have 10 multiplied by, open the bracket. You see, I always open the bracket. 0, this is point 6.
0.2304.
Close the bracket. Raised to power what? 2.
2.
Then multiply by, open the bracket again, 0.4,
4.
close the bracket, raised to power what?
3.
How many of us got this?
0.2304.
I got it.
Sir.
0.
I did.
2304. Sir. But
Yes.
excuse me, sir. If we didn't use 0.6 or 0.4 and we use 60%, then the 40%. That's when we get. Sir.
Okay, go ahead.
That's when we get 23040000.
And
So
that
how do we
means you must
convert
make
it back to
everything,
decimal place?
you multiply it by 100 again.
Okay.
Multiply this one by 100. What do you have?
Okay, sir.
23.04.
Just say multiply by 100. It depends on the 2.20. When you see comma there, comma means point to. If you've been to South Africa or Southern Africa, you will see them. They don't use point. They call it comma. What we call point, they call it comma in different places. I've taught in South Africa before, and I know what I'm saying. They call it comma, and you must use to that. And any other part of the world too, they do the
and
same.
the French-speaking countries.
Okay, somebody raise up your hand. Evelyn.
Yes, sir. Sorry. Yes, sir. I got the 10, but I used the analog way. I just want to know how to do the 5 combination 2 using the calculator.
But you got it.
Yes, I got it using the way you did it for us the first time, the analog way. But just how to use it on the calculator, I just need to know.
Okay, that's fine. So, another question. In your exam, they can give you something like this, number 3, or in any question, they can say, if n is equals to 5, p is equals to 0.6. And we can obtain probability values for 0, 1, 2, 3, 4, and 5. So, sources. So they now ask us to calculate this. They said the sequence of this value constitute the distribution of interest. Don't forget, the sequence of this value constitute the distribution of interest. Number one thing you need to know, probability when you have, remember S is equal to small x equals to n combination x, P of S, Q of n minus x. That is, probability of S equals to 0. What will happen to this? What is our n in this case?
5.
You already been given n. Our solution is here. N is equals to 5. P is equals to what?
0.6.
0.6. What is Q?
0.4.
0.4. If you ask me, it's already given 1
Yes,
minus P.
1 minus P.
Yes. So in this case now, you have N to be 5 combination 0, 0.6 raised to power what? 0.
Raised to power 0.4.
0.4 raised to power 5 minus 0. 5 combination 0 is what? 1.
1.
Multiply by anything raised to power 0 is what?
Is 1.
1.
Is 1. Multiply by 0.4 raised to power 5. So go to your calculator again. All these cheap question, don't joke with them. Just say a bracket 0.4 raised to power 5. What's the answer? Multiply by 1. You will still get it. Multiply by 1 again.
0.01024.
That is it. So you do it for 1 to 5.
Wow.
So the answer is
0.01024.
0.024. Adam, you raise up your hand. Let's do S equals to 1. 5 combination 1. Let's quickly do them. Just punch your calculator 0.6 raised to power 1 and 0.4 raised to power 4. Remember 5 minus 1. 4. So P of 2, please everybody press your calculator and do it because we will need the value now. 5 combination 2, 0.6 raised to power 2, 0.4 raised to power 5 minus 2. They can give you all this and ask you to solve some of their probability. 5 combination 3, 0.6 raised to power 3, and 0.4 raised to power 5 minus 3. Then probability of S equals to 5.
Combination 4, the last one.
Yes. Was it is 5? We are going to 5, right?
Yeah, you said five
He's talking
combinations.
about,
Three instead
he's
of five
talking about
combinations.
the combination 3.
Okay, thank you. That means you are following. So that's what we asked to calculate. Root is asking, how do we get 10 in the previous question? That means this is your first time in this class. Press your calculator is there. Follow the method. This particular method that I use, you can follow this one. Just follow this method. Or you punch your calculator, either of the two. If you use this method, you will get it. I think I've answered that. Okay. Okay. Asana, the Lord is your strength. Take it easy. You can watch the video later. Okay, so I believe we have the answer for them. Now, if the question comes this way, Abosa de Adenike, you raise up your hand.
Yes, sir. Good morning, sir.
Good morning, ma.
Yes, sir. The board is not showing on my side. Then my network went off. I couldn't get you.
Where do you stay? Where do you stay?
Ibadan.
Where in Ibadan?
Challenge.
Where in Ibadan?
Omolete.
Friday, what's the meaning of that?
Oh, you're from Molete too.
You can see. Oh.
Are you a monitoring spirit?
Where do you stay, Nike?
Ibadan.
Where in Ibadan?
Akpata.
Okay. Maybe all those rocks, they are the one that block the network. That is the network. Actually, you will see it now. Can you see it now? Or just shift yourself a bit to where this network is strong. It's the network. Sorry for that, but you can still cope. Just be hearing my voice and be writing the one you can write. Later you watch the video. That's why today, by the special grace of God, I will make the video available. I will try. Okay.
Okay, sir. Thank you, sir.
But that does not mean you should not write too. I think you can hear. Don't use that period to go and sleep. The man will upload. Because of you, I can change my mind.
Don't change your mind, sir.
So the question says, for example, they can ask you a question that find the probability that S greater than 2. Are you getting it? You already the question, what you are calculating now. Let me show us the way it look like. You have to calculate this. You have your S, you have the probability, right? So when S is equal to 0, what's the answer? When S is equal to 1, the answer 2, 3, 4, and 5. When S is equal to 0, we have 0.01024. What is when is equal to 1? Anybody?
0.010.
Anybody for 2? Anybody for 3?
0.2304.
Which one? Just tell me the one, the X you are talking about.
2.
The one of 2 is what?
0.030.
Wow.
Is it correct?
No.
0.2304.
0.4.
0.2
30.
is 0.0.
No,
Or
0.02304.
4.
The second, when S equals to 1, is it correct?
It's not correct too.
It's
Oh,
not
yeah, what
correct.
is your own now?
What
Just
I
tell
have
us.
is
0.0768.
0.0768.
Is 0 points.
0768.
Okay. When S is equal to 3?
0 plus 0.345.
3, 4,
56.
5, 3.
6.
56.
Okay. When is this 4?
0.2304. Sorry.
0.2.
0.2259.
2, 5.
Now get you.
92.
Lavia Kalau.
92.
9 words.
92.
92.
Yes,
Who's
sir.
that? Listen.
Okay. Is there the last one, please?
0.0776.
0 points.
0776.
0.76.
0.0777.
777.
Okay.
Then 6. No. Okay.
You said 777 now?
Yes.
That's correct.
Okay. Okay, now the question now says we should find the probability of S greater than 0, S greater than 2. If they ask you that, how do you solve it? I believe you know how to solve it now. It simply means probability of S equals to 3, S equals to 4, and
S is equal to 5.
S equals to 5. That's all. You already have the value of the probability of each of the S, right? Just get the one S is equal to 3, this one, add it to when S is equal to 4, add it to when S is equal to 5. Then you get your answer. Please, sir, how do we get the value? Which of the value? Aruna. Can you unmute yourself and talk, please? Okay, let's proceed.
So I think he meant these ones. This 0 point. What is
I've already gave us. We got all the value here. From here.
How is he arrived at, please?
From here. You are the one that calculated it. You gave me the value, and I put the value each of the X. Have you seen it? When S is equal to 0, we find the probability. When S, we already given N, and they gave us N and P. So that is why we solve it like this. They can have series of questions from here. Please take note. Okay, let's proceed. Now, in case they ask also calculate, if they ask you that, okay, what is N? They said P raised to P of S greater than 1. When P of S greater than 1 is what?
So we'll start adding together from 1.
You add from 1.
From 2.
From what?
From 2, sir.
From 2 or
Yes,
from
sir.
1?
From 2.
From 2.
Okay.
From 1, sir. From
No,
two.
from two.
Greater than one. Greater than
Yes,
one.
now greater than one means you're going above one. So
Look
that
at the
would be
symbol.
two.
From 2.
Greater than.
Equals to or equals to one. That means from one.
Okay, greater than
Greater or
means-
equals to 1.
Okay, from 1.
Now, please take note of that. Now, let me quickly give us this. Measure of a binomial, measure of binomial distribution. The measures, when they ask you to calculate the mean, I don't need to prove it for you at this level. The mean here is just to say n multiplied by p. They can ask you to find the mean of a particular binomial distribution. If they ask you to calculate variance, is n multiplied by p multiplied by q. We all know where your q is equal to 1 minus p. All these things are there in your book. Please do yourself.
Bring your board down small.
Are you okay with this?
Down, sir.
Okay.
Is it okay now?
Yes, sir.
So, let it be on record, please, and let's try as much as possible. I believe every one of us on this platform do get email from me.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Now,
Yes, sir.
you do me a favor. We call something a review of students. I want you to, from lecture 1 to the end, I want you to do a kind of critical review or a kind of rating. I want you to rate them and send it to my email, please. Once I get up to 40, then I will also upload the video for you. Which one is hard now? It's simple now. Just
sorry, sir, you mean
listen now.
today's
You have, yes, you can send it from today. Once I get up to 40 today, I'm fine. You still have the email. If you don't have the email, Friday, can you please put it on the chat?
Okay, sir.
Bring your board down.
Is it okay?
Yeah, it's okay like that. Thank you.
Please, I don't understand what he said. He said we should do what?
Yeah, a kind of review.
Review what? The lectures?
Yes. Not to write the notes, just your comments so far about the lectures, about the lectures, the deliverer. Was the lecturer delivered?
You will see more than 40.
Okay, like grading.
Yes,
Okay.
yes. Just to grade or to rate. Whether high, low, medium, it depends on your perspective. And make sure you write the name of the course at the end of the day. I think I have something like that on my system. Maybe I can show you the way it should. I'm not too sure whether it's still here.
You need.
We do that here. A kind of comments from the students is a huge aspect of our course here. So I just want to show us, let me see whether I can get a sample from. Okay, look at this now. Look at what the one I highlighted now. You don't need to write your name. The way this person explained is just like this line. It doesn't take too long. You write it. So you just put it. This was a best mathematics professor I've had at particular school. His presentation skill and this and this and this. Another one puts, professor is excellent teacher, blah, 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 blah. I'm not saying you should write it the way you feel. In different courses, especially for this course. I don't know about other economics.
And we are not seeing it too.
Yeah, I will copy a
Where are we going to get it?
You don't need
writing your
own word. I just give you example on your chart now. That's what a student sent for, because we use this one as also part of, you need to just make it a numbers. You don't need to know your name or whatever. Yes, use your email, it doesn't matter. So I will appreciate it at the end of the day. Please do that.
You said we should do it for all of the videos. Is it possible to just make
no, not all the videos. At least
select
you can see you might select. You don't need to watch them. Some of you have watched them. You know the one you know.
Yeah. Then you select the name.
You just give you a summary overview, your own overview about the course.
Okay, sir.
You understand? So, okay, let's move on. So this question now, when they ask you this, they ask you to find the mean, you know what to write. Are we given assignment? Hey, Adenike, Madam Akpata, it's not assignment, it's just a review, please. So, like the question I gave you the other time, let's look at this one too. Let's say one. If n is equals to 25, p is equals to 0.02 for a binomial distribution, they ask us, then I said, find Roman figure 1, P of S equals to 1, Roman figure 2, P of S greater or equals to 2, Roman figure 3, P of S less than 3.
I'm not seeing the board.
Is your network. Better beg them so that they can release your network. So we know the first thing to do is to get your Q. Is that okay?
Yes, sir.
Get your Q and substitute your X. That is, the solution will be N is equals to 25, P is equals to 0.02, Q is equals to 1 minus 0.02. What is the Q?
Just a second.
0.98.
0.98. So for P of X equals to 1 is what? N combination X, PX, Q, N minus X, which is equals to 25 combination 1 and 0.02 raised to power 1, then 0.98 raised to power 25 minus 1. Punch your calculator, you have your answer. So you do the same thing to the other. So let's quickly move to, but we'll still come back to this. If I check, I will excuse me. You look at the questions.
Sorry, sir.
Thank you. So let's look at the Poisson. Poisson distribution. Poisson distribution is defined by X. A Poisson Can you please mute yourself?
Come again, sir.
A Poisson distribution is defined by X and lambda. We call this one lambda, meaning this is what they call lambda, where our X starting from 0, 1, 2, and so on. And lambda is equals to what we call mu, or mean. We call it mean. And the formula for Poisson is f of x equals to p of x equals to xi. This is the same thing as exponential minus lambda raised to power s all over s factorial.
Please come back again, sir. I can't see the board.
It's your network. There's nothing I can do, madam. It's your network, please.
No, so your this thing is shaking, sir.
My head is shaking. Wow. Which one is shaking now?
The screen. It will zoom and it will.
It's your network. Others are not complaining. If you are the only one, it simply means it's network. Don't worry. Just
it's
manage
fine.
it.
It's the network. It's fine. It's the network.
Just manage it. Today is the last day. Don't worry. It will not shake next time. Okay, let's move on, please. Let me show you something here from your book here. So, unfortunately, they mentioned table, but I will just explain how Poisson works. Let's look at the application here. They said Poisson distribution is used in many areas of business, especially.
So I'm not following you. I don't know if
better.
it's in the book, so that will follow.
Don't
because
worry.
my screen is not.
Don't follow on the screen. Just listen. I'm not writing. Can you please mute yourself? Okay. Sorry for that. Poisson distribution is used in many areas of the business, especially when we are interested in reducing the waiting time on the queue at the filling station or petrol station or garage or cafeteria, at the ATM queue. Some of the area in which Poisson distribution has found application. Number one, arrival pattern of student at a location of water tap. For example, remember when COVID came, they said, some schools said, all of you should not resume at the same time. Let year one resume by 8 a.m. Year two, 8:15. Year three, like that. Primary one, primary two, or GS1, GS2, GS3. So they try to apply Poisson distribution here. They now said arrival pattern of car at a petrol station or a customer at the restaurant. Typographical error in a book, demand for a product, and so on. Now, what we normally mean is the characteristics of Poisson is number one, the occurrence. The occurrence of an event, of the events are independent. That is, occurrence of an event in an interval of space or time has no effect on the probability. They can ask this question, that which of the distribution deal with occurrences? Please, let's take notes. A second occurrence of the events in the same or any other interval. Number two, theoretically, an infinite number of occurrences of events must be possible in the interval. I will explain. All these things, you can read them on your own. But here, I don't think, okay, let's look at this question. They said, suppose the number of guests entering into class restaurant is Poisson distributed, and the average number of guests entering into the restaurant in an hour is 10. What is the probability that in a given hour, 2 guests enter the restaurant? What is the probability that 2 guests enter the restaurant? Unfortunately, here we don't have the table. I will have used the table to explain. But what you can do is, I want to beg you, take your time and read up some of these examples. If you have any question, you can let me know. I've already explained to you the way you will solve them. For example, look at this. Here is the MP that is equals to mean. They can ask you the relationship between approximation of the one I circle. Please go and circle it in your book or page 177. Go and check it and see how you can. So, but let me go to the normal our past questions.
So please, can you repeat that that place you circled? It's not clear in the textbook here. It's faint.
Oh, and what I just said is the same thing. Why is it not clear in your own textbook? It's the same way.
It's not clear.
No, what they did here, you are not to prove. Don't cram yourself. Don't just give yourself a headache. Remember, I said mean in binomial is equals to NP. But mean in Poisson is mu. And you can only get the mu through the MP. That's what I was trying to explain to you. Are you getting it now? That is N multiplied by P, the probability of success that we are talking about. Am I clear now? Okay. But in this case, several things are involved. Let's proceed. Let me just open the question. Some of the questions, I was still going to drop some of them, like as I promised you the other time. You don't need to do the screenshots. I will send it to you. Don't disturb yourself. Okay, look at this question 13 now. They put it here. Okay, I think we've solved something. It said, for a standard normal distribution, I don't know whether your textbook covered normal distribution. Sorry. I think it covered. You can just read their, because of the time, we can't go in detail. All you need to do is there.
Yes, sir.
Yes, sir. The idea I will give you, everybody, is go and check when you get to normal all the other distribution. Just know their formula for mean variance. The same way probability is being solved is the same. The same way, please. Is the same. Let's try as much as possible and solve them. Is that okay? Just go through them. If you have any question, let me know. But now let's go into the question. Some of these questions, I think I highlighted some. So they said here, look at this. They said a standard normal distribution. What is the value of mean variance? When mean is equals to 0, variance is equals to this. I didn't get this question right. What they are saying. Okay, they already give them the question up. Let's check. There are questions that are following each other. I will send the material as I promised. The past question. I'll send it to you. I think this one is not that clear. Let me put this. Okay, no, not this one. Okay, now let's look at this one. You read this number 83. Can you see number 83, please?
It's blurring, sir. I can't even see clear.
You left it there.
It's blurring.
It's not clear, sir.
It's not clear, right?
Yes, sir.
Okay.
Yes, sir.
It is your network most times. Sister Favor is sleeping.
No, sir.
Okay, let's look at this. Let me reshare my screen. So that would now lead us to going. Okay, let me explain. What we are trying to do is the pool, they ask us from the pool, says, if the mean of binomial probability distribution is 25, then the mean of Poisson probability distribution is what? And they now told us from this, our book, that Poisson distribution can be used to approximate the binomial distribution when n number of trial is large and p or probability of success is small. They now said what they mean is, remember the Poisson distribution. The mean for Poisson distribution is here. Poisson. This is the one of binomial. The one of Poisson says our mean is equals to mu. Poisson distribution is saying that. But binomial says our mean is equals to MP. And then I said MP was given in unit 15 as equal to the mean of binomial distribution. How do we know when n is large and p is small? Generally, it is accepted that for n to be large, here n must be greater than or equals to 20. For p to be small, p must less or equal to 0.05. That is, p equals to 0.05. So to show the approximation, we shall given this and this and this. That is, our n is large. They now show us the concept here. That, okay, at this point, n is 25. We consider it to be large. That is, it's greater than 20. Or p is equal to 0.02. Remember, it's less than 0.05. So they now said our MP is equals to what? 25 times 0.05, which is the same thing as 0.5 in their own way. But now, in this case, with the question on the pool, who can tell us the answer? Yes? What is your answer, please? Put it in the chat. Put your answer in the chat.
This one is not entering now.
You don't, it's not the number, it's not the entry. I'm not teaching you, we are solving a question. What is the answer for that? It's obvious. The answer is there, but you just have to tell us. Somebody should tell us the answer. Yes, Esther Egba. Somebody said one. Which one? Where do you get the one? How?
It's 25.
Yaya,
It's
you said
25.
120, 1.25. Okay. Somebody said 25. Somebody said 120. Okay, I like that. So let's continue. Let's throw the answer there. Don't be afraid when I call you. I'm not calling you to embarrass you. I'm calling you just for us to discuss. Just feel free.
And the one was a mistake.
You said?
The one was a mistake.
Okay, no problem. Anybody, please? $0.5. How do you get 0.5? 5.25. Read the question again, please. 45 is number, is not part of it, though. It's just a question. If mean of binomial probability distribution is 25, then the mean of Poisson probability distribution is what? That is the question. You don't need to solve anything. Yeah.
Yes, sir.
So the answer is
How do you get 25, please?
Because they already showed us that the mean of binomial distribution is equal to Poisson's distribution mean. So it's the same thing. As long as they've given us the answer of the binomial mean. So that means we are going to have the same answer for the Poisson means.
Okay, thank you. Any other person? Any alternative?
No, sir. From our formula.
Me, Kehinde, you put 20. How do you get 20? Please? Mr. Solomon, you put 0.5. Where do you get it?
And 25 times 0.02.
Where do you see 0.02? They did not give you any value now.
Any value? That means that will be 25 now. 25.
Where do you see O2? That's what I'm asking.
Because of the they said the mean will be 0.05. I mean it's supposed to be 0.05.
No, there's no mean. They only give you the question direct. Are you getting it now? The
mean will be 25 now. 25.
Exactly.
Yeah, 25 will be 25. 25.
Sir, you are muted, though. We can't hear you.
Oh, thank you. That is, the mean is equals to the mean for the binomial is the same thing, is the same mean for the Poisson anytime the n is large and your p is small. Please take note of that. And here, they did not tell us whether n is small, n is large. Do you get it now? So automatically you assume that the mean, they are the same. Any other question?
Thank you, sir.
So let's look at another one before we call it a day. I will still share the...
Come again, sir, please.
Sir, please go back to your board.
You said?
Go back to your writing board.
My writing board, what do you want to see there? I want to pick question for you now.
No, sir, the mean formula for these poisons.
It's just mu.
Sir?
The mean formula there is mu. Now, wait, I will give you some question now. Let me just quickly do it on the pool. I have some other questions. They are all for you today. Don't worry. Today now.
Hello, sir.
Yes, ma'am. Go ahead.
Yeah. Okay. You said the reason why the answer here is 25 is because they did not state whether there is large or small. So let's assume they state that n is small or big or something like that. What will not be the answer? So I'm confused on that. You said the reason why you said the answer is 25 is because they didn't actually state whether one is bigger or one is smaller. So we will just assume that the answer is 25. So what if they state that one is smaller and one is small for this same question? Is it possible? And if yes, what would be the answer, please?
You already answered the answer. The question, you've already answered it. If you look at what you said now, assuming they said the n is bigger, we all know the formula when n is bigger, n multiplied by p. That's all. You understand my point? N multiplied by p at that point will give you the value.
Okay, thank you, sir.
So, you're welcome, ma'am. So I have this question for you guys, and I believe you enjoy it. Everybody, please solve it. Don't just say, can you see it now?
No,
Yes,
sir.
No, sir.
No. Okay, you will still see it. Don't worry. It will come up. Or your network again.
I don't think it's network. We're all not seeing. Okay.
Can you see it now?
Yes, sir.
Yes, it's up.
Mhm. The first question says what? Somebody should read.
Probability of success.
Increases in binomial distribution, binomial probability distribution if the value of probability of failure if the value of probability of failure, yes, that's what's there.
I
Probability
think something is caught. Let me check. Okay, look at question 2.
I'll show you.
It's not showing.
Yes, sir.
Question two says if mean of binomial probability
You can see they
distribution is
repeat
25.
the same question in different way now.
Yes.
Okay, the same question, the same way, but in another year.
Okay.
Are you getting it now?
5. Yes, sir.
Take note of that. Now, look at this question, the third one.
Mean of binomial probability distribution of 857.6.
That is the mean.
Yes, sir. And probability of success is 64%. The number of trial in this binomial distribution is dash.
You remember the way we solve it? You remember the solution?
Yes, sir.
What will be the solution for number 3? Anybody?
Approximate.
Are you to approximate? Don't say what are they saying is not clear. It is clear. It is better you follow the trend before it is too late. So they ask, you are given the mean. You are asked to get the number of trials. You are given the mean, MP, and they gave you what? P to be 0.64. They now ask you to calculate, to look for X, to look for the number of trial in that case.
We are looking for N.
N. So what will be? So we have almost like 10 questions in each year that contain probability or more than that. I think we need to call it a day here.
Sir, please, can you help us with that number 3, sir? Because it's somehow challenging.
Number 3, what happened to it?
It's somehow challenging for us to get that N.
Number 2 question.
Number 2 question.
I didn't get it.
Which one?
That question 2 and question 3.
Number 2 is the same 2 I've solved before now.
You solved number 2 before.
0.64. What question 3? N is equal to N is 857.6 divided by 0.64.
What is the value?
$18.4.
For what, please? Which one?
Number 3, sir.
Number 3.
Yes, sir.
Okay. Some of us cannot get the question. Let me quickly check. Okay, thank you. Somebody has copied the question on the chat. How do you get 18.3?
I said 13.3.
How?
I did 857.6 divided by 64%.
Were you supposed to do that?
No.
Remember, you are looking for N.
N. Is the value is supposed to be when I think it would have been higher than that. Don't get divided in 0.65 and 6.
Okay. Number 3 is 13.4. Is it 13.4 or 1,300?
Yes, sir. 13.4. 13.4.
How many of us agree?
Yes, I agree, sir.
You agree? Okay. How many of us disagree?
I disagree, sir.
You disagree?
Yes, sir.
Okay. What is your own?
My own is 548.864.
Oh.
I multiplied 857.6 by 0.64.
Where did you get the 0.64?
It's in the question. That is the percentage, 64%.
Okay.
86.4.
It's supposed to be what?
I said I multiplied my own and I got 54886.4.
No,
Okay.
it's 548.864.
548.
I got
864.
548.864.
Oh, okay. And some people agree with the first man.
Yes.
So which one should we agree on now? It's getting interesting.
Let's solve together.
Aruna. Yaya. Favor.
I don't know how to calculate it too.
Yeah, it is together. I'm struggling with my that is not coming up.
I will not deceive you. Expect something like that. So,
Please, can you help us with the correct answer?
I know we are in it together. I mean, I don't know too. Somebody just said we are in it together. Okay, let's.
Trouble.
If you look at the question says we should get N. Let's go to the binomial distribution again so that you will understand what we're saying. From binomial distribution. I gave us this formula. I explained this to Ross. You remember? I said our mean is the same thing as MP. Variance is the same thing as MPQ. And we know MP, we know MPQ. Our N, look at it. the number of trial, and we are given this. They gave us the entire this. And the question says, we should get, we are given mean. Let's say we are given NP, right? To be what? We're given, they said mean is a simple mathematics that we all need to know. And 857.6 is equals to n multiplied by p. We all know that. Do you agree?
Yes.
What is this? We are looking for n. We don't know the n, but they gave us this. So it simply means that it's just, we said n. What is p?
0.64.
0.64. Do we agree?
Yes.
Yes.
Remember, you are still given, they gave us this. Just cross multiply. Your n will come out. That is, divide both sides by, just divide both sides by, sorry. Divide both sides by the value here. Make n subject of formula. That's what I did. This one cancel this one. It remain n, because we know from here, from our definition, n is number of our tire.
Yes, sir.
And from the pool says what? Mean of binomial probability distribution is equal to this. And the probability of success, which is P, is equal to 0.64. The number of trial in this binomial distribution is what? Are you getting it now?
Yes.
It's just a simple thing.
Very clear, sir.
So 857.6 divided by 0.64, what is it?
1.340.
1.34.
40.
1.34.
Is
Is
it
it 13.4? 1.34.
13.4.
1,340.
1.340.
1 point that is there is comma.
There is comma, it's 1.340.
1.340.
Don't fight now.
Sorry,
It's here.
1340.
Let's use the calculator.
1,340.
Yes, that is it.
1,340.
Wait.
1,000 there.
It's here. 8
57.
57.6. Can you see it?
Your calculator is not showing, sir.
So, I'm not seeing what you're doing.
But use your own now.
Yes, sir. Our own is 1340.
1,340.
1,340.
There's
There's no
comma,
point.
there's comma, there's points.
Yes,
after
now
one.
comma is.
There's no point.
Where you see your point?
Comma is.
Hello. Can you see my calculator?
1,340 naira.
Yes, sir.
1,340 naira.
0.64.
She like money.
Is it naira or dollar?
Can you see the money? Can you see it now?
Correct, sir.
The end. Don't make mistakes. They will give you the one with point. They will give you the one with comma. 1,340.
Okay.
That's the end. I think I've solved a problem today.
Yes,
Thank you,
sir.
sir. Thank you, sir. We appreciate it.
Yeah, too much.
In your own case,
Don't forget to write review.
If you don't write review, you will not get the video, no problem. Once I see the review, then I will release your video.
Teach us next semester.
Which one?
It's taking you the next semester course too.
Which course are you doing next semester?
SCT 206.
Go and pass this one first too.
I mean I believe you passed already. If at least
Yes,
I'm
sir.
sure of those of you guys in class. I don't know about others. For
Yes,
the
I'm
fact that you
sure
are coming
I'll
to the
pass it.
class
We'll
and you do
pass.
all the exercises that we are giving ourselves, and you follow the simple instruction, mathematics,
I will pass.
statistics is just a walk away.
And
Like
watch out the
the one
recorded
we
video, I will
solved
pass.
together today now. So it will help us. And I will also try as much as possible to see.
So if you are not the one to set the question, is a problem. Or
if
you are not the one to set the question, so it's going to be a great problem.
It's not going to be a problem. Listen to
Big
me.
problem.
It's not going to be a big problem. If you have that mindset, it will be big for you. But if you believe that, okay, the question we solve now, am I the one that set it? No.
No.
All you need to know is just know the method of solving the problem. That's all.
Yes, sir.
Just create that mentality that, okay, all I need to know is to pass this course. How do I pass it? I will upload the questions for you now. Some of the past questions. What you need to do to help yourself at this late hour.
Thank you, sir.
You don't need to thank me. You can only thank me when you pass.
Definitely.
So the major
Yes,
thing
we
is,
pass, sir.
Yes, for you to pass. That is why we are saying, and for you to be able to teach the set coming after you. You can teach them tutorial. It's not big deal. It's just a small thing. Just create the time, go through over it, and solve them. I know some of you say, me, I know I'm not passed. You say I should teach people. Yes, you will teach. You will teach them, and they will come and meet you. You will teach them, and make sure you teach them well. So please, that is the way to grow, and that is the way it's supposed to be. Let's try as much as possible anywhere we find ourselves, and just make sure you impart 1 or 2 lives. Don't go that you want to impart the whole generation. Just one person is fine.
So you were saying something before that
I
wanted
know.
you to finish.
Which one? Naomi.
That you said for us to pass. You are saying it before someone cut you
You
short.
like to pass. See, that is what you
Especially
just put your head. The only word you want is pass, pass, pass.
Anita.
Okay.
Anita.
For you to pass, it's very simple. The questions, all the past questions you have access to, even not statistics alone, to all the courses. I mean, I'm not saying summary. Don't get it wrong. The past question. Past question. Solve all the past questions. Get used to the pattern of setting. Don't cram any of the past questions. Don't say they are repeating it. Who told you? Or else you will just eat your head. But by the time you study the rate of setting the question, it will help you to prepare. You will know the aspect you've covered. You can tell me that, hey, sir, probability question will come. Remember, we've done a lot. We've done probability. Let's go over. You will see some of those things we've done in the class. So all those things we've mentioned in class, how do we get the data? Don't say, hey, that one is too small. When I have probability to read, go and read them. Read those data too, they will come. They are there already. So don't be deceived. Me, I need to go and read, starting from the cover page. Read them. Look at the number of things they listed here. Only 2 topics we did not touch, which is hypogeometric distribution and normal distribution. And I've told you the secret. Go to those 2 topics and lay your hands on it. I'm not promising you. If I have time, I can do 1 or 2 short video on them and show you how you solve them. But I'm not promising you that. But I want you to
appreciated, sir.
I want you to go and solve this. Now let's come back to this. How do you pass? Remember, your TMA is 30. Thank God for your life. You have 30. Congratulations. But you can fail.
It was
Not this semester.
So does it mean people did not get 30?